Good morning, guys. It is Monday, September 14th. Happy Grandparents' Day yesterday to all you grandparents out there. Um, Today we're going to work on more acceleration. Okay, we're going to work on the formula. This first worksheet strictly deals with calculating acceleration. Okay, so I've got my worksheet here, so we're going to work together. We're going to look first at the formula, and then I have got 6 problems here dealing strictly with acceleration. We're also going to go over this tomorrow. You will work the same problems. We're going to read them again, work through them again. But that's just going to kind of reiterate the importance of knowing that formula. Then we're going to go and we're going to look at how to calculate time using the acceleration information. Instead of looking for the acceleration itself, we will be given acceleration, but we will be looking for the time. So we're going to kind of flip that formula and look for another component of it. Okay, first of all, let's look at the formula. Average acceleration is your change in velocity divided by time. So in order to find the change in velocity, you have to have final velocity minus your starting or initial velocity. All right, number 1. A car increases its velocity from 0 meters per second to 14 meters per second in 2 seconds. Okay, so in order to find acceleration, we have to plug in those components. So we automatically can see 2 seconds. That is our time. Okay. Then our starting velocity would have been 0, final velocity 14. So the first component is the 14, the final velocity was 14. And for this one, I will put the units, and the ones to follow I won't, but I will put the units at the end, which is meters per second squared. Final velocity goes first, minus initial velocity, which in this will be 0 meters per second. Okay, so when you do the math, and I will give you a second, if you've got your calculator, which you shouldn't need for this one, you would end up 14 divided by 2 would be 7 meters per second squared. That's very important. Don't forget to put the squared. That is the unit for measurement of acceleration. Okay, so number 2. A bicycle rider increases his speed from 5 meters per second to 15 meters per second in 10 seconds. Okay, so again, get your formula set up using the information that we have to plug in. We can see immediately our time is 10, initial speed and final speed is what we need now. Increases his speed from 5, which would be initial speed, to 15, which would be final. Final goes first, as you can see here. Final speed 15 minus 5. So 15 minus 5, 10. 10 divided by 10 would be 1 meter per second squared. Okay, let me get my paper moved up here. Okay, number 3. A racing car's velocity is increased from 44 meters per second to 66 meters per second in 11 seconds. Time on the bottom, final speed increased from 44 to 66. 66 is final, 44 is initial speed. So there you're going to have 22 divided by 11 is going to give you 2 meters per second squared. Okay, moving right along, number 4. A train moving at a velocity of 15 meters per second is accelerated to 24 meters per second over a 12-second period. Okay, so let's find the acceleration. Time, that's usually going to be your easiest component for this formula to pick out in the problem. Okay, so the velocity of 15 is accelerated to 24. So 24 will be our final. 15 is our initial. Okay, so 24 minus 15 gives you 9 divided by 12. Okay, this is simply doing the math here on top. 24 minus 15 is going to give you 9. There's the 12. 9 divided by 12 is going to give you 0.75 meters per second squared. Okay, number 5. I'm trying not to get it all crooked. There we go. A plane starting from rest is accelerated to its takeoff velocity of 75 meters per second during a 5-second period. Okay, we immediately pick out the time. So starting from rest, we know that that's going to be 0. That's the initial, so that's going to go here. Remember, initial goes here, final goes here, and we know that our final is 75 meters per second. So 75 minus 0, of course, is 75, divided by 5 would give you 15 meters per second squared. And the last one before we move on to our next part. A ball rolling down a hill for 9 seconds accelerates from 3 meters per second to 34.5 meters per second. Okay, we say that the time is 9. Final accelerates from 3. That's going to be the initial. 34.5 is going to be your final. Final goes first. 34.5 minus 3. Okay, when you do that math, and I'll give you just a second to do that on your calculator, you're going to do 34.5 minus 3, and that's going to give you 31.5 divided by 9. It's going to be 3.5 meters per second squared. Okay, so let's take another look up here. The formula for acceleration: final velocity minus initial or starting velocity divided by time. Okay, so what happens when we have a problem that gives us the acceleration, but we need to find the time? Okay, so let's look right here. We just looked at acceleration. Okay, we know acceleration is final speed minus beginning speed divided by time. Okay, and this is just another way of representing the same formula. Okay, so what if, like I said, we have acceleration? What if we're looking for the time? Okay, and this right here is going to be your formula to find time. You're going to have time equals final velocity minus initial velocity divided by acceleration. And I know I'm using abbreviations here. I'm trying to save a little time. Okay, so it's the same formula. We just kind of flipped some of the components. All right, so let's look here at one example. This, you're looking for acceleration. Okay, you can see a skater increases her velocity from 2 meters per second to 10 meters per second in 3 seconds. What is the skater's acceleration? We just did a whole page of those. So let's go on down and look at an example of trying to find the time. A car accelerates at a rate of 3 meters per second squared. So there's our acceleration. If its original speed is 8 meters per second, how many seconds will it take the car to reach a final speed of 25 meters per second? So this will be initial speed. This is final speed. Okay, so let's plug that stuff in. We are looking for the time. We are going to plug in the final speed minus the initial speed divided by the acceleration. And again, we notated all of those components up here in the question. And when we do that math, you get 5.7 seconds because we are looking for time. Okay? So let's flip over and we're going to look right here. Let me get my camera fixed again. Okay. While traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the automobile's acceleration? Okay, this is another example of finding acceleration. So we will skip that one. I'm sorry. I should not have done it. Let's go on down to number 4. Okay, look at number 4. We're going to look at how to find time. And the rest of these we will do in class tomorrow, where we are finding acceleration, but we just did a whole worksheet on that, so I don't want to waste any more time. Let's jump into finding time. Okay, number 4. A car traveling at a speed of 30 meters per second encounters an emergency and comes to a complete stop. How much time will it take for the car to stop if it decelerates at negative 4 meters per second squared? So we are given acceleration. Okay, car is traveling at a speed of 30 meters per second and comes to a complete stop. So the final velocity is going to be 0. Initial velocity is 30. Okay, so let's plug those things in. And remember, you're going to have final velocity minus initial velocity divided by acceleration. And that's going to give you time, not acceleration. So let's plug those things in. Okay, final velocity is 0. Initial velocity is 30. Acceleration is negative 4.0. So how many seconds? We are looking for the time. How many seconds will it take if the car decelerates at negative 4 meters per second squared? So go ahead and try to do that math. Remember, you are looking for time, not acceleration. So 0 minus 30, negative 30, divided by 4 will give you 0.75 seconds because we're looking for time. Okay? All right, so let's go on to the next part. I can get my stuff together here. All right, let's go ahead and look at the rest of these, okay? So this one, a helicopter's speed increases from 25 meters per second to 60 meters per second in 5 seconds. What is the acceleration of this helicopter? So here we are looking for acceleration. Okay, so let's go ahead and get our formula set up. On the bottom, when you're looking for acceleration, that's where your time goes. And we can say that time is going to be 5 seconds. The initial speed would be 25 because it tells us that the speed increases from 25 to 60. So final minus initial. So 60 minus 25. Okay. When you do the math, I'll give you a second. Okay. You're going to end up with 7 meters per second squared. Okay. As she climbs a hill, a cyclist slows down from 25 miles per hour to 6 miles per hour in 10 seconds. What is her deceleration? So deceleration tells us This is not a speeding up. This is slowing down. Okay, so on the bottom, easiest part to pick out is your time, 10 seconds. Okay, slows down from 25 to 6. So final would be 6 miles per hour. Initial would be, let me separate that a little bit so it's not confusing. Final would be 6 minus 25. Okay, so go ahead and do that math. Remember, on top, you're going to have a negative divided by a positive, which is going to give you a negative answer because this is deceleration. Okay, slowing down. A negative acceleration means slowing down. So go ahead and do the math on that one. Okay, you're going to end up with negative 1.9 miles per hour. Okay. Now, let's go ahead and look at let's skip number 11. We'll look at that in class tomorrow. Number 12. A cyclist accelerates at a rate of 7 meters per second. How long will it take the cyclist to reach a speed of 18 meters per second? Okay, so what are we looking for? We're looking for how long. So we're going to be looking for time again. Okay, so let's go ahead and get our problem set up. When you're looking for time, acceleration goes on the bottom. So the cyclist accelerates at a rate, there it is, acceleration, 7. Okay, how long will it take the cyclist to reach a speed of 18? So to reach, that's going to tell us that that's our final. Okay, so initial would be what? 0. Okay, so 18 minus 0 divided by 7 is going to give you 2.57 seconds. And I think it ended up being like 2.5666. So you're going to round that up to 2.57. Okay, we will look at the other one tomorrow as well in class. So you've got this video now. That'll give you some examples to look at. All right, so when you, tomorrow or this afternoon, I'm going to be posting an assignment. You'll have one worksheet to do, and it's going to be on acceleration, deceleration, and formulating time using acceleration information. I'll go ahead and tell you too, you're going to have an assignment. It's a chapter review. We're going to go ahead and have our first chapter test. You're going to do a chapter review. You're going to do pages 38 and 39, numbers 1 through 20. That is for a grade. Okay, and I understand those of you doing Reconnect, you've got your textbook. That's all you need. You can write your answers. I would prefer you put them in a Google Doc and send those to me through Google Classroom. Okay, and then on Thursday we will be having a chapter test. Okay, so I wish you guys luck. Let me know if there's anything I can do for you.